Hello everybody. Today we are going to see from object oriented case tools 10.4.4. In last lecture we had completed till check your progress 3, and now we will complete the rest. Let's begin. Object oriented case tools are similar to other case tools. These differ from others only in terms of their capability to create class diagrams and text specifications for reports. Object-oriented case tools support an O2O methodology such as Rumbaug's Object Management Technique (OMT). Examples of object-oriented case tools. A large number of object-oriented case tools are available in the market. These include Paradigm Plus from Protosoft, Rational Rows from Rational, and With Class from MicroGold Software. Our discussion here will describe object-oriented case tools in general without making references to a specific product. The following are some of the features found across most of the object-oriented case tools. Number 1. Create graphics such as class diagrams, message diagrams, state diagrams, etc. Number 2. Create text specifications such as system specification, class specification, and relationship specification. Number 3. Generate source code. Number 4. Repository of models. Differences between various types of object oriented case tools. All of these object oriented case tools are similar in terms of their capabilities to create class diagrams, code generation. However, they may differ in terms of their extendability, number of supported operating systems, and additional features and capabilities such as support for different methodologies and computer language code generation. C++, ADA, Java, etc. Most provide capability to automatically generate code of C++ and other languages from a class diagram and class specifications. Some provide the capability to generate class diagrams from code. Reverse engineering figure 10.5 depicts drawing and text tools. An object-oriented case tool has the capabilities of drawing class diagrams and state diagrams. Specification tools create text reports. Case tools, drawing tools. Under case tools comes drawing tools and specification tools and text editors. Drawing and text tools. Figure 10.6 depicts major outputs of object-oriented case tools. Diagrams. System diagram, class diagram, and state diagram, under which comes text specifications, system specification, class specification, attribute specifications, and relationship specification. Then comes source code, C++, ADA, other languages source files. Figure 10.6 Major outputs of object oriented case tools. The class diagram is core to object oriented design. It describes the types of objects in the system and the static relationships between them. The core element of the class diagram is the class. In an object-oriented system, classes are used to present sorry classes are used to represent Entities within the system. Entities are often related to real world objects. Figure 10.7 depicts the class diagram for a typical banking application. So here we can see figure 10.7, a class diagram for a typical banking application. Okay. Then comes figure 10.8, an example of a simple class contact where we have contact like address, city, pin, country, and like name, attributes, operations. Here we can see, okay. So here the name, which is contact, attributes, address, city, pin, country, and operations, read function and print function. Then we have creating documentation and reports using object oriented case tools. A system requirement describes the condition or capability which a system must conform to, either directly from the user need or derived from or stated in a contract, standard, specification, or other formally imposed document. Most of the object oriented case tools assist in documenting as well as in object oriented analysis and design. Object oriented case tools have capability to import graphics from other tools. The system requirement is given shape in sketches with pencil and a paper. Then it is used by the drawing tools and text editor available to create system design, class diagram, and other diagrams. Document processor does it all to create a model document from these models. Figure 10.9 depicts the process to create a model document. So here we can see figure 10.9, process to create a model document, system requirements, rough sketch with pencil and paper, case tool, drawing tool, text editor, document processor, model documentation. Figure 10.4.6, creating an executable prototype using object oriented case tools. Most of the object oriented case tools greatly assist in creating executable prototypes based on design specifications. The diagram below shows how case tools are used to create executable codes. System requirements are prepared in text and diagrams by pencil and paper. Design specifications like class specifications, system diagrams, and various text specifications are then generated using tools available in case. From this, design specification codes are generated using code generation tools. Most of the case tools support generation of C++ code, whereas some may support other languages as well. The source code generated might require updation with formulas, expression, etc. Case tools also create updated diagrams based on updated source code. Figure 10.10 depicts the process to create an executable prototype using a case tool. Figure 10.10, process to create an executable prototype using a case tool. So here we can see the diagram. Okay. Then comes sequence diagrams. UML provides a graphical means of depicting object interactions over time in sequence diagrams. These typically show a user or actor, the objects and components they interact with in the execution of a use case. One sequence diagram typically represents a single use case scenario or flow of events. Sequence diagrams are an excellent way to document usage scenarios and to both capture required objects early in analysis and to verify object usage later in design. Sequence diagrams show the flow of messages from one object to another and as such correspond to the methods and even supported by a class slash object. Figure 10.11 shows an example of a sequence diagram with the user or actor on the left initiating a flow of events and messages that correspond to the use case scenario. The messages that pass between objects will become class operations in the final model. So here we can see a typical sequence diagram for deposit into account. Okay, so here we can see the diagram, it's now clear a bit. Then comes check your progress for, and it will be soon available in the description. Let's see the summary. Changes are occurring in traditional way of system development. Organizations use case tools to improve integration and development activities. The tools also help standardize the development process. Computer aided software engineering CASE automates part of system development process. A case tool provides iterative and interactive tools for various activities like user interface design and code generation. Modern case tools are aimed at supporting the entire activity of system development. Hence, case tools known as one case integrated case has evolved. Case tools are classified as front end tools or back end tools depending on which part of SDLC process they automate. Front end tools automate initial part of SDLC process, whereas back end tools automate process that come later in SDLC lifecycle. So here we come to the end of today's video. So thank you and check your progresses. Answer will be available soon in the description. So remember to check that out. So thank you. Until then, keep exploring.